So now we move on to the panel discussion, for which I now invite Molly Morgan from Exawatt, Christian Combs from Huasun Energy, and 𝗩𝗀𝗏𝗏 from GCL SI.
Hello.
Hello, everyone. We meet again.
Hello.
So, coming to the end of our two-day TaiyangNews conference, we have seen presentations about some new products from the leading total solution providers, but that's just a selection of hundreds of new products presented during SNEC and Intersolar this year. So my first question is to all of you that, what are the three major trends that you have identified this year? And if you can share what you think has changed most when you compare it to last year's SNEC and Intersolar events.
Molly, maybe you go first.
Yeah, I'll do a quick summary. So I think to start with your second question, in comparing product innovations to last year, I think it's clear to see how the situation of oversupply has impacted manufacturers looking for alternative ways to reduce costs and being quite clever with these different ways of achieving that. And one of the examples in my presentation was the frame and the alternative frame materials to aluminium. And I guess it's worth noting here that there have been manufacturers looking to not just use alternative materials, but also reducing the content of material in things like frames. And we were able to get a bit of intel on that through conversations with frame manufacturers. So I guess, yeah, lots of innovations with materials usage, including frame trends.
𝗩𝗏𝗏.
The trends, I think I know it's very clear, and the discussion was all around TOPCon, heterojunction, tandem. So if I look 1 year back, we were all very focused on heterojunction. We were not speaking that much about tandem and perovskite. We were, but not as we are today. So I think that it's very clear that we are in a TOPCon time. So this year, next year, the mainstream, even if we have back contacts, even if we have heterojunction, it's a TOPCon, the mainstream. But we are expecting news for 2026. And now I think that the question is, we speak about these three mainstreams, the heterojunction, the TOPCon, and then tandem, and we have now doubts about what will really be the next steps. I also agree with Molly that one of the things that we see now is that manufacturers trying to adapt to the reality of today regarding the costs by being more creative with components and designs. We hear speaking about thickness, where we are reducing the quantity. We heard speaking about silver, that we need to find a way to not be so much dependent on that. So I think these are the main topics that we take.
So from my side, the topics that have been mentioned now are clearly the main. I'm going to name something completely different. I think that what this year has been clear is that energy management, in terms of how it combines to energy generation, is becoming more and more important, more critical. We, the module people, have become the commodity that has to work well. So the value of our proposition is shifting more and more into making sure that it's reliable, that it lasts for so long. And the highlight goes into maybe battery systems or alternative application methods like vertical that will squeeze more value out of the same energy of the solar modules.
Okay, so materials and energy management. Okay, so getting deep into it now, let's start with upstream with wafers. So Christian, LONGi recently introduced a new wafer technology, which is also its base for latest record cells and modules. Does this really make much of a difference? Are you getting the quality that you need for your cells and modules?
It does make a difference. Let me spread this a little bit, this information. When we talk about heterojunction modules and TOPCon modules, TOPCon cells have a high sensitivity to the content of oxygen and metallic impurities. So better material makes a big difference in that technology. For us as well, in different components of the material quality, not in the amount of oxygen and impurities of metallic impurities. And what happens here is that we are opening the door to having a spread of cost-effective materials. This means 𝗩𝗶𝗿, GCL was talking about that, and other methods that are maybe innovative and maybe useful for heterojunction and not for TOPCon, to have a lower cost of the wafer. And then other methods that are more premium and give an advantage as well to heterojunction or to TOPCon. And we get a spread. So right now we can offer our customers the basic power, let's say 715 watt, just normal. But if the customer comes and says, I want 10 watt more, we squeeze with the materials 10 watt more, and we produce 100 megawatt of that. Or if they come and say, we want really, really the lowest possible price, we go to 700, 705, and we are able to reduce the cost on that. And this kind of flexibility in the past was more like, we produce and you get the low tail of the production to some low cost, because we cannot get rid of it, or you get a higher end. But it was not a decision in manufacturing. And this is changing thanks to the different characteristics of these source materials. I mean, I see Vitor smiling and saying, yeah.
Yes.
They are the source of these things, right?
Exactly.
You have used 𝗩𝗶𝗿, you just mentioned?
Yes.
You have. Okay.
So maybe a bit deeper on that. When you have different production methods of polysilicon, you get different resistivities, different content of oxygen, different content of metallic impurities. When you do heterojunction with them, you do in the process at the beginning something on the cell surface to remove all of these things that are not good. And with heterojunction, the good thing is that you don't subject the cell anymore to high temperatures. And with PERC and TOPCon, you heat up again the cells when you do the process of putting impurities. And that heating up brings back up all of the impurities and makes it so that you need a higher quality source material to make the cell of TOPCon or monoPERC for that matter, compared to heterojunction, due to these very small details in the process. That's something that is quite important. So we have access to lower cost. We buy from them as well, I guess. Material that doesn't need these requirements.
Okay. Vitor, GCL is a fully integrated company with it has its roots in manufacturing of silicon and wafers. So according to you, what has been the key development in the upstream segment in the last half year? And we're not talking about new wafer formats apart from that. So what's that upstream development in the last half year?
Yes, I think that I will mention too the 𝗩𝗶𝗿 importance now, because now regarding the emissions and the cost-wise, like Christian was saying, you consider it in a vessel. We see the 𝗩𝗶𝗿 being more and more requested. As you know, we also sell silicon to our model competitors, and we see also the increasing. Even, and let me just give you a number, even if we now, this was one of the questions in the chat, that the silicon cost is not as representative as used to be. So now we speak that 15 to 20% is silicon. And I started some years ago where the silicon was 60, 70, 50 for a while. And now we are speaking 15 to 20. So there is a change on the impact of the cost of getting your silicon, but also that the 𝗩𝗶𝗿 silicon right now is quite interesting from the emission and the cost point of view.
Okay. Probably both of you can also share if you have something to talk about this upstream development.
I agree with that. The upstream development on the polysilicon source is the most important development in the last time. I fully agree.
All right. So now let's come to the wafer formats. As yesterday in our presentations, on day one of the conference, it was very clear that rectangular wafer-based modules are the new mainstream. And when they talk about this, they usually refer to container utilization. Molly, you also mentioned higher module efficiency. So what is the major driver here?
Maybe,
Yeah,
sorry, Molly, go on.
No, that's okay, you go.
So from my background of the years that we have been trying to implement the best module sizes for the container utilization, The point is that when you have a module that is 2m38, that is the module with the highest length that you can put on top vertically on top of a pallet inside of a HQ container, and then it reaches almost the top, but you can still move it in and out, right? If you have modules put horizontally, let's say like this, right? On a pallet, the maximum width of the module is 1m13.4, because then you can put two pallets one on top of each other and you reach exactly the same height of the two pallet compound. So this defines both for a vertical pallet module, this means the G12 modules, the length, and for not G12, like rectangular or even M10 modules, the width. That's why it's 182. Maybe you can go to 182.1 or something like that, but probably not. And that defines those dimensions. Once you go to each option, basically from that point on, the utilization of the container is maximized already. There are small differences, but with the modules that go like this, you just start to put them on the end, and then you define how wide the pallet is to make exact amount of pallets in, but sometimes you don't want that because it becomes very difficult to take them out. So there are slight differences. And typically now, if you have more pallets in the container, it will be more difficult to take them out. And if you have just a couple less, it will be easier to take them out. So one cost probably cancels the other in a way that we are at the optimum, because we cover all the height of the container, and we ram them all in until we cover all of the depth. Then you have some additional things, like most of the vertical pallets, you include in the container a couple of tools to work with them. So a tool where the module pallet, once open, is laying on this so it doesn't fall over. So you need some space in the container for that. But it's also optimized that basically that has brought us to the width 182 for one option and the length of the wafer 210 for the other option, and then the combination.
Okay. Molly?
Yep. So as we've discussed, there's a lot of optimization with the different wafer formats to fit into containers, which is really important to utilize the space, as we've just heard, because otherwise you're not utilizing the whole of your container and losing cost there. But also there are other advantages as well to do with the electrical parameters of moving to a rectangular wafer. So you've not just got the physical optimization, there are also improvements with the electrical parameters as well, which can in turn improve the power ratings and then the efficiency outputs of the modules. So a mix of the physical optimization and also some beneficial electrical parameters too.
Okay, interesting.
And maybe I can add just one comment. I agree totally with Christian, and I think that one very important topic is also the transport cost is something that is very hard to control, that we get a lot of negative surprises with things that happen. So the transport cost is, as much as we can optimize the number of modules that we send for a container, the better. But I also agree with Christian, sometimes it's just a little bit strange because you optimize the number, but then you get more trouble to unload the modules. And regarding with Molly, I would just like to add one thing. I totally agree that optimization is not just about the transport, it's also about electrical parameters. And for example, regarding the rectangular cells, we saw the 182 times 191.6 very used. And now we see a lot of manufacturers transiting to the 210 times 182. And this allows you to decrease the voltage, increase a little bit the current, but have a more balanced module. So I think that is both ways, is the optimization because of the transport cost, but also the optimization regarding the solution for the electrical parameters. And we see that change now that most of the manufacturers are looking with the different eyes to the 210 times 182 with less cells.
Okay. So today in Molly and Christian's presentation, there were different views on the development of M10 and G12. So while Molly sees it going into the direction of M10, Christian sees it the other way. So can you try to find some consensus here? And 𝗏𝗏, you can also share your opinion.
I think you gave the consensus. It's a naming issue more than anything else. Vítor, he is on the supply side and he's giving the direction very clearly that M10 as itself, by itself, is not really so relevant anymore. But maybe in your statistics of Moly, either you have like the whole amount of datasheets that are from the past, or you put this rectangular inside of M10, because I didn't see we call it internally either G12R or 210R. It has many names. And if you put it inside of the M10, correct, even if it's actually based on G, on almost square, then it's inside of there, then I would agree on that graphic. I don't know, Molly, how was your criteria?
Yep. So we do, to answer one of the questions that came up then, when we do our datasheet surveys, we look to the a year and a half's worth of recent product announcements. So we try not to include anything that's too out of date. But then with the split between M10 and G12, there is, as you say, that sort of almost a naming disparity between some manufacturers labeling where the side length has one common side length between M10 and G12. Sometimes there's a bit of confusion between which is sort of the basis wafer format. But we do see the split between M10 and G12 to stay as the dominant two wafer sizes, and we forecast that to continue. But then there have been some conversations that we've had with industry members that have started to consider looking at a larger format past the G12 dimensions, whereas we don't see that at CRU. We don't think that will be a dominant wave size in the future. So although we are sort of standardizing with the M10 and the G12, mostly the M10 from our data set, standardizing between the M10 and the G12 wafers and the rectangular formats, it's a bigger question as to whether manufacturers will reach consensus on what they believe to be the most beneficial wafer dimension, especially when there's so much range and so much variety out there in the minute.
Yeah, speaking of variety, there is no standardization in rectangular wafer formats as well, because there are 182 by 210, 182 by 183 by 0.75, 182 by 199. So what is the final word for the coming years? 𝗏𝗏?
Please, this is all yours.
I think that after what Christian and Molly just said, I think that what we can take out of that is that they're based on 210, start to make more sense. We are seeing that, like I said, we see also the transition from these different rectangular size like 199.6. We are focusing more on 210, 182. My estimation, because this sector surprised me many times and it's very hard to predict, is that this will be the trend. Okay, I don't think, I was very glad to hear Molly say that she also doesn't think that we will grow more than 210. So that is also good from my perspective. And I think that this will be the rectangular size that will be the biggest trend. 210, 182.
Okay. All right. So, and when, the larger wafer formats, when they came to the market, lots of companies, teamed up to work on standards and industry ecosystems. Yesterday, Trina was talking about a new group that works on very large 700 watt plus modules. So Christian and 𝗏𝗏, how much is this helping? And are you joining it? Or
I cannot comment if you join in any group until we sign. So sorry for the no answer. Generally speaking, there was this group for 182 and then it changed because everybody started doing other things. And there was this kind of group for 210 and it changed because everybody started doing other things as well. So I don't know. In heterogeneous, we have made a group called the 740 plus club. Based on that size, just because the numbers are so easy to say and we can apply the technology to other wafer sizes, right? And all of these positions where the industry gets together and tries to share experience are good, because what we don't need is a situation in which customers get problems and issues that one brand has solved and the other brands don't know about, for instance. So that is quite important. We see now with the corrosion of aluminum mixed terminals in TOPCon that could be solved, and if somebody doesn't do it, then it's really bad. There should be more information exchange in industry. Every attempt to go in that direction is welcome from my side. Of course, the details will define if it's useful or not.
Okay, so from my side, I came from that world. I came from the standardization world. I worked 14 years in a TIC company, and I know how hard it is to get standards and agreements in these kind of discussions. But I totally agree with Christian. We have the institutes, the laboratories, the independent laboratories, also with a lot of work now to check the reliability of new solutions. But if we have groups where we can have open discussions, where we can share experiences, this is good for the sector, especially with so many news and so fast development. Because here the time is crucial, but can also be an enemy. If we do the things too fast and we don't share experiences, we can, more than having a standard, I think that we need to go to come to the market when we have a new design and a new technology with a very strong opinion about the reliability of the technology, and not always have, I don't know if it will work. Let's wait 1 year to see if we have track record to see how it works. So we cannot avoid this totally by these groups, but they can help. And we will try to be present as much as possible in these discussion groups.
Okay. Just before we go on to the cell technology, just one question. Power sizes are still going up. Module format has reached its max because of the container limitations, right? So this 2384 by 1303 is max to fit in the container. Is that what we are saying?
Yes and no, because the industry always has surprises. From the point of view of the height, yes. From the point of view of the width, in theory, you could go even wider, but most customers want to be less wide rather than wider. On the other hand, you have hundreds, I would say more than 100 gigawatt for sure, of 210 modules installed everywhere that are performing perfectly fine. And maybe some people will say, look, let's make them even a bit wider and we gain 5-10 watt more. We go to 135. I don't know. It could be an option, because from a mechanical point of view, from the cell mechanical point of view, it is fine. We see tests done, the mechanical typical test with 33-35 millimeter frames for big size modules, passing with flying colors, with glass, with better results than less than 2 square meter modules had 7 years ago. Like no micro cracks visible anywhere, power degradation less than 1% after the extensive testing. So from the mechanical point of view, there would be still room for going a bit wider. So maybe somebody will do it. I don't know. I think, I don't know if it makes sense, but sometimes marketing makes sense. So one player goes a bit wider and then they can put a higher number in the datasheet. We'll see.
I agree, Christian. I just add one note. I think that if that happens, we will face again the trackers and the structures manufacturing. Not, let's say that we will not make too many friends after that, because it's just starting again the compatibility discussion. So probably we will stick in these dimensions for a while, at least the width.
Okay, great. So moving on to cell technology now. Even though quite some PERC modules have been manufactured and shipped this year as well, I think it's safe to assume that TOPCon is the new standard. This year, it is supposed to take the leading market share according to ITRPV, and that also expects it to, stay the market leader for the coming next 10 years. So, Vitor, do you agree with this?
No. No, honestly, 10 years, no. We heard a lot of things today, and the experience I have been 18 years in the sector and still get surprised. And for example, during my presentation, I said that we are anticipating what we want to do with tandem. And 1 year ago, if you ask me 1 year ago, I would say have a totally different speech. So honestly, I believe that things will happen from 2026. Not probably to have exactly a mainstream change in 2026, but I think we will still see the start of it. So 10 years, I don't agree, honestly.
Absolutely in agreement, I think. And then there is the other thing, the other point is that when do you call a technology a different technology? Because we have seen very nice presentation from DAS today, and they have been doing enormous improvements on TOPCon with efficiencies that go beyond what's actually on the market, right? So lab, nice. And there's a point where you wonder, should we still call it the same name, or is this something new? And in that regard, I think that the current generation of TOPCon has a short run, but maybe we call it differently in the next one, and it will be leading in the next 5 years. But so the unspoken truth is that all of the tandem technologies achieve very high efficiencies with very low cost today, or some with low cost today, but they are all struggling with durability. And the question mark will be in the next 3 to 5 years to see how the market accepts a product that is on paper much better, but maybe has a worse warranty condition or not proven reliability. And then to see how this actually is entering the market. That will be the game of the next years, I am assuming. And if the market follows my personal thinking, many of the players at utility scale make business plans that are actually limited to maybe 10, 15 years, 20 years. Inverters don't last 25 years or 30. Even mounting structures like trackers will probably need to be replaced after 10 or 15 years. So maybe we will see some developers saying, okay, I take 15 years for everything. And then I'll take this module that only has 15 years durability. It's quite okay. And it's so much cheaper, much better. And then we'll go with it. We don't know. We certainly don't know. For us, if we see that, we see back contact cell basically on rooftops. It looks very nice and it has higher efficiency. Heterojunction back contact cell, maybe. TOPCon back contact cell, maybe. PERC back contact cell, probably not. So there are some ways that look facing the end, some other ways that may have an exit out. But we will see. It's very exciting the next 5 years. I fully agree with Victor. The discussion will be on the cell technology, on if and when tandem comes in, under which conditions. And then as heterojunction, TOPCon, or whatever is in utility scale, it will be a level fight. I personally think heterojunction will have the overhand, but there is a point. Right now, many of the players are not making a lot of profit, let's put it that way. So I don't know if many of the players will have the cash necessary to start installing 100 gigawatt of another technology, full installation plans, even if the product is better. So we will see how this moves.
Molly, do you think what will be the role of HGT in the global cell technology mix going forward, with TOPCon taking the lead?
Yeah, so I definitely agree with everything that's just been mentioned on the sort of time frame to the end of the decade and when we might see tandems come in to displace a bit of market share from TOPCon. But from our in-house cost modeling, we struggle to see a way that heterojunction can we're not saying that heterojunction won't have a role to play, because every technology has a role to play and has its applications, with heterojunction and back contact each having their own specific areas where that technology may thrive. But we just are more cautious on heterojunction displacing a larger share of TOPCon's market share in the next few years, while the manufacturing costs sit at that little jump higher than TOPCon. But then between the two technologies, between heterojunction and TOPCon, as it was mentioned, it's a very sort of level game in terms of efficiency improvements, and it's always interesting from one quarter to the next to see what heterojunctions like just gained ahead a little bit, and then the next quarter you're like, oh, okay, TOPCon's caught up. So between the two technologies, in terms of efficiency at least, it's definitely an open race to see which technology can just hold that efficiency premium.
Maybe I want to do a small comment on that. From the outside, as not manufacturer, you have a limited window of visibility on the cost. And maybe let me just give a broad description. In terms of silicon material, heterojunction is already cheaper than TOPCon because the wafers are thinner and you can source either the same wafers or you can use materials that are not possible to be used with TOPCon because they would not make a good TOPCon cell or even a cell. So you can source cheaper the kilogram and you use less because you cut them way thinner. Ryzen was showing 90, we are at 100. So that's definitely an advantage in the material. In terms of silver use, it has been shown that heterojunction has caught up, reducing the silver use to the level of TOPCon. And then we have the other part, which is the machinery. And the main reason why the machinery was more expensive in terms of CapEx was the fact that there was not so much demand. The process itself of making the cells, making the module is not very different, right? The stringing and all of that, you can just put it all at the same. But making the cell is actually a more simple process from heterojunction compared to TOPCon. But the moment that you have a healthy market of 100 gigawatt of companies buying machinery for heterojunction, you will probably have equal or even cheaper machinery cost at heterojunction side. So basically, we are stuck with a cost that is less for heterojunction, with the exception of the TCO or ITO, which is the kind of cost that we are trying to make it fit into the level of cost that will be similar to TOPCon. Many of those developments have been happening in the last few months, so maybe the information sources for this cost modeling have been a little bit out of date. I suggest you contact any of us and we can give you a bit updates on that.
Okay, moving on to back contact. Vitor, you said that your company is planning to launch back contact. So what would be your strategy? It's kind of a...
So we have smaller designs also thought for that model because like Christian said, and I also agree, we see also back contact a very interesting application for distribution. Okay, so for rooftops, for commercial, industrial. It has higher efficiency, it looks better. It has a lower bifacial coefficient. So if in utility you are thinking about high albedo installations, probably you can find other options. But we see a niche of market for this technology due to the efficiency, to the aesthetics, but also due to the application. So the cost, let's say like that. So we will launch it launch to be already delivering in the Q1 of next year. So we are already taking some orders or promoting this with our clients.
Okay. And while most companies have their perovskite and silicon tandems on their roadmap, GCL is already producing perovskite modules. So what do we have in in terms of commercialization for this technology?
I cannot give many hints on the technical side, like I said, but I can give you more or less our milestones and our idea. So we have the single perovskite module certified already with the IC, but you know that this is not the version to be commercial. And the tandem one, like I mentioned during my presentation, our estimation was to start our pilot projects in the beginning of 2026, and we are anticipating for last quarter of 2025. So this is also a good way to generate track record experience, but in real projects with real clients. And we already contact most of them. We have already closing some deals with them. It was even over our expectation. Our interest was for the especially big IPPs. As you may know now, some of the IPPs also have these installations where they compare technologies for their own knowledge and their own decisions. In this case, we have a little bit of mix of real projects with not too big dimensions like 10, 20 megawatts, and some pilot projects in these testing installations of some IPPs. So 2025, we want to start to install these modules, then also evaluate the behavior of the modules together with the clients and start to have it as a market mainstream for 2026.
Okay, great.
And regarding efficiencies, we are now achieving 28, and our aim and what will be our target to make these pilot projects is 30 minimum but we are aiming for 32.
Okay, interesting. Molly, yesterday, I don't know if you had a chance to attend the presentations, but JS Solar talked about application-specific module design. So, modules made with different BOMs for various applications like deserts, oceans, humid climate, cold climate. So do you see this as a trend, especially now when the cost pressure is so high due to overcapacities?
I think hard to say whether it be a trend at this early stage, but it wouldn't be surprising if that were to happen more and more, given that cost is such an important driver of the industry and innovations at the moment, as we all know about the inventory that's caused all the low pressures that have remained on prices. But if it were to continue and manufacturers were to continue to look at having different BOMs for the specific applications, I think it would make sense to it would be a good area of innovation, especially like relating everything back to frames, like I was discussing earlier, when you think that some of the innovations, okay, they might be really beneficial in terms of cost and they might come with a 10% cost reduction to your frames, but obviously a change from aluminium to steel has knock-on effects to the weight of the frame and therefore the overall module. So one innovation and one tweak to a cost-saving module innovation might have a knock-on effect on another parameter that might make something not so good for another application, like especially if it's an ocean application like you mentioned in the question. So I think if it were to become a trend, it would be something that we would welcome to see and would be a good area of research for manufacturers to really tailor those products and be able to apply those cost savings without compromising overall design of a module.
So let's ask the manufacturers themselves. Are you guys doing? And
I fully agree. I don't really have much to say, Molly, in everything. There are applications we do for them, but okay, maybe a detail. And most of the time when we look at applications and then do something specific is because they have elevated requirements. If you only have normal requirements, you will just use the same standard module that is used the cheapest to produce and just adapt it somehow, different clamp, whatever. But we're looking at floating, which requires additional protection against humidity. We're looking at vertical installation, which requires a different frame or even frameless. We're looking sometimes at BIPV, which requires a different module design, and so on and so on. So most of the time, or we're looking at coastal areas with different, similar to floating, let's say, we're looking at additional requirements that require a BOM that is better in the sense that somehow more adapted, and it will have a costada. If the application can pay for it, we will definitely do it if the market segment is big enough. Yeah, this is the history of photovoltaic. We have been doing that for many years. Most of the time what happened, historically speaking, is that the standard module became good enough for doing those applications without any more changes, and the specificity of that requirement disappeared because the standard module somehow managed then to cover that. It's like glass coming to cover floating. Now the specific module is floating on salty water. And for instance, we have a specific line for that, right? So increased requirements. Salty water is mostly not even allowed for glass, so you need something special.
From myself, I totally agree with Christian. I think that many times the modules, the standard modules and the development of the standard modules gave you the answers for some needs that you have. You mentioned some, but I can, for example, the desert conditions. I remember when we were trying to develop a standard for the desert conditions. Just to give an idea about also in line with Christian, in GCL, we found a niche or an opportunity for this kind of applications that is Caribbean area, where you have strong winds and then you have the corrosion because most of the installations are very near the ocean. So for example, we develop a composite frame with special clamps for this. And it was interesting because the first cell we did was not in 𝗂𝗍𝗿, was in France for a chemical atmosphere, because the resistance to the corrosion of this atmosphere is much better with the composite than with the aluminum. So wrapping it up, I think in the line as Christian says, yes, we can look to some special applications. There's very specific niches of applications because most of the standard modules, with some adaptations or no adaptations, they can fit.
Okay, so let's talk about the Zero Busbars again. Do you think this technology is fully ready with all the issues addressed on cost, reliability, and performance level? And when do we see it fully taking over in the sector?
So maybe I have to call back to my presentation. For heteroaction, it is ready. There are several options to do it, and the key idea is that Zero Busbar. Let me just skip one. So, okay, I hope you can see it. It still looks like there are busbars, right? So it's not. This is the most common misunderstanding. When we say Zero Busbar, busbar is what's screen printed on the cell, and already super multi-busbar does not have a busbar. It has soldering pads, right? And that for heteroaction has been solved already because there are several technologies that were developed in the last 2-3 years, and they have been thoroughly tested, and every supplier has chosen one of them. And I think most of the suppliers, at least us for sure, we have passed the 3 times IC under the strongest conditions. And in reality, the results are better than super multi-busbar. The idea being that the ribbon, which is the little wire on top, actually gets contacted to the whole cell and not just to the soldering pads. For heteroaction, generally, this is just a better reliability. And the point is just to have a manufacturing process where the manufacturing is easy enough. And that has been achieved. So it's now in mass production, and we're changing our manufacturing as fast as we can to Zero Busbar. In TOPCon, it's a bit different because TOPCon Zero Busbar connects to the fingers, not to the surface of the cell. And there are other reliability issues about migration of copper into the PN junction because they don't have TCO. It's a bit more complex, and there are some approaches and some are maybe close to implementation, but I don't think really in mass production implementation yet, unless somebody tells me they are doing it, and then I will correct.
Okay, to wrap up, we'll have the last question from all 3 of you. So what innovation of the last 6 months do you think will have the biggest impact?
The last 6 months.
Mass production of Zero Busbar, successful mass production of Zero Busbar for me, because perovskite tandem is not the last 6 months. Otherwise, I would say perovskite tandem, but that's been going on for longer. Zero Busbar, widely implemented in heteroaction, is bringing in 2025 cost parity for heteroaction that will have a massive impact.
Okay. Vitor?
Yeah, it's very hard because the last 6 months, besides these Zero Busbars, there are not that much. If it was 1 year, we could speak about the other technologies and the changes about the parameters and so on. I would say tandem, but again, I agree with Christian, it's not within the last 6 months. So the Zero Busbars probably.
Molly?
Yeah, I think that's a full house for Zero Busbars, and it's been really great to see the amount of product on display at the trade shows, even though some of them might not be quite in mass production yet or are still slightly in development. It's going to be interesting to see more and more different ways of achieving Zero Busbars on display over the next year.
Okay, I think that's a good way to end the presentation, the panel discussion with a consensus. Thank you, Molly. Thank you, Christian. And thank you, Vitor, for such an interesting and insightful panel discussion. Thank you for being with us today.
Thank you. Have a nice day.
Thank you.
Thank you. Bye-bye.
Thank you.
Bye-bye.
So With that, we come to an end of our two-day virtual conference on Global PV System Technology Trends H1 2024. Once again, I'd like to thank all our sponsors for the conference, LONGi and JA Solar, Diamond sponsors, Huasun, Jinko Solar, and Trina Solar are Platinum sponsors, Astronergy and Tongvi Solar are Gold sponsors, ICO and Ryzen Energy, the Silver sponsors, and GCL, DAS Solar, and DMEGC Solar are Bronze sponsors. Let me quickly remind you that all TaiyangNews latest solar PV technology reports and market surveys are available for free download on our website under report segment. So do look them up. Here's something interesting. TaiyangNews will be at RE+ in California in the US, where we will be hosting a physical event one day before the trade show starts, which is September 9, 2024. And we have teamed up with EUPT Research for this. So the discussion will center around manufacturing solar wafers, cells, and modules competitively in the United States. You can find the link to register for this event on our website under our events tab. So if you're at RE+, we would love for you to be there. With that, we end today's virtual conference on Global PV System Technology Trends, H1 2024. We hope to see you for our next virtual conference on solar and sustainability on August 27, 2024. You'd find details for this event on our website. So, till we meet again, keep reading TaiyangNews. Thank you for your time today.